We just got 2 more school days till your EOGs begin. So, not much longer. Getting there. We've order for those last 2 a little bit. Pick up your laptops today. Make sure y'all don't screw them up too badly. They're poor testing. Since we did scientific notation on Desmos, want to go over that while we still have the laptops. Volume, we mainly used, you can do it on Desmos obviously, but we mainly used the yellow calculators. It goes a little quicker with those. So we'll do the volume stuff tomorrow, and we'll do the scientific notation today. I was too lazy to flip-flop the list though, so just left it as is. Make these scientific notations. Sometimes, occasionally you get lucky, something like that. Nice and hopefully easy on your EOG. All right, so A there, where's my decimal go? Between which 2 numbers? Between the 4 and the 2. So I got 4.267. Our front number there needs to include all non-zero digits. Also needs to include any zeros that would be in between any of those non-zero digits. So if there would have been a 0 like between the 2 and the 6, I would need to include that 0. But any zeros at the end, we don't include those. Then we got times 10. What would my exponent be? 7. We count the digits after the decimal, that's the exponent. When it's a big number like that, and 42 million counts as a big number, positive exponent. All right, for B here, where's my decimal go? Behind the 8. Let's get a little more specific. Left or right of the 8? I'm not sure if this is a math problem or a left and right problem. It's going to the right of the 8. All right, so we're going to have 8 times 10, and you could see that as 8.0, but that's not really necessary. And what we're doing is we're counting the digits in between. It gets a little more difficult, especially like from your seats like this, because there's no commas. It's not impossible, but like I said, a little more challenging. What should my exponent be? It's going to be a -7. I got 6 zeros and the 8 in between those decimals. And when we have a decimal, it's going to be a negative exponent. Okay? And yes, that way for y'all is to the right, not the left. And that's the side where the decimal would go, okay? We need a single digit number, so decimal's coming after the single digit number. All right, so we're looking for which one would have the same value as 3.652 times 10 to the -4th. All right, so if I got a negative exponent, big number, little number? Little number, so that's eliminated, right? So that means we're looking at A or B. How many zeros am I going to end up having? 3, because we already got that 3 in front, and my decimal's going to move over 4 spots. So what we're doing is we're filling in 3 zeros. The 3 zeros are going to be like right there. Makes A our right answer. This is one of our units, obviously, so hopefully a little fresher on that. All right, try to figure that one out. We need the number between 600 and 6,000. Greater than 600, less than 6,000. Landon? C is correct. All right, so 6.1 times 10 to the 3rd, that's going to be 6,100. That's too high. 5.9 times 10 to the 4th. I don't know why I wrote a 4. Oh, because of the exponent, I guess. That's not how that works. 5, 9. That's 59,000. The 5.26 times 10 to the third, that's going to be 5,260, which is between 600 and 6,000. The 7.87 times 10 to the third is 7,870. That one's too high. Okay? Any questions on that? Probably less likely than something like that. Which one's in between? You might have to like drag and drop, kind of putting them in order. But it'd be the same basic kind of idea where you got to be able to, assess where they fall. Put it in scientific notation and standard notation. Let's just get an answer in scientific notation. All right, so we got some division. 8.4 times 10 to the 10th divided by 3 times 10 to the 7th. That's that one. Your answer in scientific notation. Bobby? Yeah, 2.8 times 10 to the third power is correct. Odds are good. Use Desmos or the calculator on this. You would have got 2,800 to start with. It's a small enough number they wouldn't have given it to you in scientific notation. But when you go to change that to scientific notation, your decimal's going right there. So you got 3 digits after the decimal. That's where the times 10 to the third comes from. Okay? Any questions on that one? All right, multiplying 8.5 times 10 to the third times 2 times 10 to the fifth. Antonio? Yeah, 1.7 times 10 to the ninth is correct. So even without Desmos. When we're multiplying, we would add exponents. So I've got 10 to the third, 10 to the fifth. That makes 10 to the eighth power. Notice that's not the answer. It's not even one of the answer choices. But when I've got 8.5 times 2, that makes 17. So I'd have 17 times 10 to the 8th. Remember, we need a single digit out in front. So when I put a decimal there, I've got to add 1 to my exponent. So that's why it becomes times 10 to the 9th. All right? Any questions on that one? So Graham's class raised $20 in a coin drive for a school fundraiser. Total amount raised by the entire school was 4.8 times 10 to the third. How many times greater was the total amount raised by the school compared to his class? What's that mean we're doing? Dividing. All right, so we take the total amount. There's the total amount for Graham's school. There's Graham's class. So those are the numbers we got to divide. We take the number for Graham's school. How many times more? Basically, how many times. So you get, what was it, 2.4 times 10 to the second power, scientific notation. That's what I asked for. Usually these problems where it's how many times won't be in scientific notation for the answers. This one asked for it this way. Probably would be looking for the 240 as the answer choice usually. Any questions on that one? Just remember, that's a very good chance you see a problem that asks you how many times greater.